Hello! In this milestone, our team, Group 13, consisting of Diego, Lindsay, and me, Johnny, dive into the critical aspect of web security and cryptic traffic analysis. We'll walk through the process of enabling HTTPS on a WordPress site, demonstrate how to configure SSL keys, logging into Wireshark, and analyze HTTPS traffic to understand what's visible and what remains encrypted.
To begin, we'll be talking about enabling HTTPS on WordPress. So before you even begin to do the steps to enabling HTTPS, we have to look into the network settings of our instance on EC2 on Amazon Web Services. So you have to go into the network settings of your instance and allow SSL traffic, HTTPS traffic, and of course HTTP. So that allows us to read it on a later topic where we're going to be analyzing the Wireshark. So once you have that setting configured, you're going to have to build or create a domain. So we use noip.com to actually create a domain and allow us to connect our IP address of our instance to that domain. And you can do that all through noip.com. As you can see, I named my website foodlovers.onthewifi.com. So after you link your instance to your domain name, right, your instance IP to your domain name, you have to connect to the instance and to the terminal and install certbot. As you can see in the bottom left picture, with there's command lines. I skipped a little bit over the parts that we did in class and showed you basically what at the very end where I was actually downloading the certbot. And matter of fact, I actually gave the certification to one of my links, which is I chose foodlovers.onthewifi.com. And once you get that certification, how can you check for your domain to be secured? The one way you can check whether or not your domain is secured, if you look on the bottom right picture, where it says the little three dots, the little swipe things. If you take a look at that and you click on it, you without it will say unsecure. It will have a little triangle if you are on Windows, and it says it's not secure. But since we have the certification from certbot, it will say secure. And as you can see, connection is secure. Your information, for example, passwords or credit card numbers, is private when it's sent to this site. So that lets us know that we have security, or we have that certification from certbot on our website. So the very next thing that we're going to be talking about today is configuring SSL key in Wireshark. So we did cover this in class, so I'm very familiar with this. So what we have here is that the very first step to do is going into our settings and finding our environmental values. Oh, sorry, environmental variables. So that's the first step. Go into your settings, add a new user variable in the environmental variables. So we're going to be naming it as is it SSL's key logs, and then you also have to put it somewhere where you're able to find it. In my case, I put it in my downloads because it was the easiest place to find. So the second step is basically find it and check if it's there, if it's working. As you can see, the second picture in the middle, that shows the SS key log, and that is exactly what is being given to me by Google. And I had to use Google to work because when I was trying to use Microsoft Windows or Edge, it wasn't working for me. All right, next thing is you have to open up Wireshark and navigate to the preferences and go under protocols to find TLS. From here, you have to add in the SSL key log to the master secret log file name section. From there, you're able to decrypt. The transaction of HTTPS, and you're able to get the TLS v3. And that's where we will talk a little more about client hello, server hello, and the exchange between the client and server. But yeah, that's about it.
Sent by the client to initiate a session with the server. Within the packet, we can see the version number, the client random, which is a 32-bit number used in the creation of the encryption key, the session identifier, and the cipher suite, which are basically a set of tools that'll help the computer and website talk securely. So basically, when the user visits a secure website, the first thing the computer does is says like, "Hi, I'm here," and the computer introduces itself by giving basic information about who it is, and the website analyzes that information and begins to build a safe and private connection. So the server hello contains the server version, the server random, and the session identifier, the cipher suite, and the compression method. So after the client hello comes through and says, hey, I'm the client, the website answers with a server hello. The website has looked through that cipher suite, and it gives the computer its identity and a random number to help create a secret code. So the server hello finalizes the plans on how they communicate, and the website is basically agreeing on the security rules and improves its trustworthiness before sharing private information.
Alright, let's break down how the server key exchange works and seen through Wireshark. When a client tries to connect to a secure server, it kicks off a handshake. But if the server certificate isn't enough to fully exchange keys, especially when we're using a cipher suite, when the server has to send a little extra help, it calls the server key exchange message. When you capture a handshake in Wireshark, you'll see the server key exchange message appear right after the server's hello and certificate message. In Wireshark, if you expand that server key exchange packet, like the example here, what you're going to find is the handshake message, specifically the server key exchange during a TSL handshake. The handshake protocol is marked as a server key exchange. Inside, we see the servers which highlight either a ECDH or a DHE parameter. The server is using a named curve which is X25519, a common secure curve for ECDHE handshakes. Following this, the server includes a signature. The signature authenticates the server's key exchange parameters and protects against tampering. This entire packet is part of securing the key agreement process before the session begins encryption.